Alright, so in this video we're going to learn how to find the GCF of a polynomial. So the GCF stands for greatest common factor, and the greatest common factor is the largest number that divides into two or more numbers. So we are going to say the largest. So I'm looking for the greatest number they have in common. Okay? So let's take a look at some examples. Find the GCF of these pairs of numbers. So what you're going to have to do, if you don't have great number sense and know what multiplies into it, there's a foolproof way to figure it out, and that's called a factor tree. So you're going to see what two numbers multiply to get 18. So I know one of them is 9 times 2. Okay, you could have said 6 times 3, anyone like that. So I've got 9 times 2. And then you need to keep breaking it down to its prime factorization. So what goes into 9? 9 would be 3 times 3. Okay? And I'm going to go ahead and bring that 2 down so I don't forget about it. So if I were to factor that out, I would get 3 times 3 times 2, which would give me 18 if we typed it in the calculator. Okay? So now I would do the same thing for 48. And so I know 48 is 6 times 8. Okay? But these numbers aren't prime numbers, so I can break down 6 even further. 6 is going to be 3 times 2, and then 8 is going to be 4 times 2. Again, I can break 4 down more, and 4 is 2 times 2. So let me go ahead and bring down all of the numbers that I did not touch. Okay? So if I did 3 times 2 times 2 times 2 times 2, it would give me 48. So now you need to see what they have in common. So they have a 3 in common. Okay. They have a 2 in common. And that's all they have in common. So if I were to multiply those together, I would get 6. Okay. So the GCF of those two numbers is a 6. Okay. So maybe you could tell that by looking at those two numbers, but if you cannot tell the biggest number that goes into two of them, then you will have to do it by hand. Okay, so why don't you try this one on your own? Find the GCF of 65 or 60 and 45. So when I did the factorization of 45, I got 9 times 5. Again, you can break down 9 into 3 times 3. So then 3, 3, and 5 were all prime numbers, so I was done. Over here, I did 6 times 10. I broke down 6 into 3 times 2, and I broke down 10 into 5 times 2. Okay? And again, 3, 5, and 2 are all prime. So now I looked at what they had in common. They had a 3 in common, so I wrote it down here. And they also had a 5 in common, so I wrote it down here. You do multiply them, and so the GCF would be 15. Okay? Now I'm going to teach you a shortcut how to do it in the calculator. This works 99% of the time, but not all of the time. Okay, so what you're going to do is you're going to hit the math button. Okay, so let's kind of write that down. You're going to hit math. You're going to hit the right arrow key. So we're going to go over to number. And then you're going to go all the way down to number 9. And that says GCD, which stands for greatest common divisor. Okay, so once you do that and you hit enter, you'll see GCD comes up. Then all you have to do is type in these numbers with a comma in between them. So I would do 45, comma, 60, and then close your parentheses, and look what it gives you. It gives you the answer. Okay, so again, those steps are math. Go over, and you can press 9, and it will come up for you, or you can scroll down to number 9. And again, you type in your two numbers with the comma in between. Okay? So it works most of the time, but not all of the time, okay? All right, so now let's look at some more examples. Okay, for a GCF in algebra class, the GCF is the largest monomial. Okay, And we know monomial means one term. So we're going to be dealing with x's and numbers from now on in algebra class. Okay? So what is the GCF of all of those terms? Okay? So the first thing you're going to do is break it down if you can. So notice 5 would just be a 5 times a 1. Okay? X cubed, if you were to break that down, you would say there are 3 x's. So it would be x, x, and x. Okay, so you just expand that out. With 25, what we have in common would be 5 times 5. And then x squared means 2 x's. And then 45 can break down into 9 times 5, which is 3 times 3 times 5. And then with just 1 x, we will put that there. Okay? So now, if I've got 3 terms, I need to make sure that they all have something in common. So I can't take a 3 from over here because it wasn't in common. So I do see there is a 5 here, there is a 5 here, and there is a 5 on the end. Okay, so 5 is going to be your numerical GCF value. Okay, now you need to see if they have any x's in common. All of them have at least 1 x, so 5x. Okay, they didn't have 2 x's in common because this last term did not have an x or 2 x's to take from. Okay, so the GCF of those would be a 5x. Okay. Now I'm sure you're asking, is there a shortcut in the calculator for this? There's not. So you can only do 2 terms in the calculator, so you can't do 3 terms like I tried right here. It said error, okay? So if you were to want to do this in the calculator, you would have to try 5 and 25 to get a GCF, and you have to try this number and this number to get a GCF, and then hope that it would be a 5, okay? So let's take a look at some other examples. Let's find the GCF of these terms, okay? So 8 can be broken down into 4 times 2. Okay. So we're going to ignore that negative sign right now. So when you see you've got a lot of terms with negatives and positives and negatives, we're going to ignore that for now. So I know 8 would be 4 times 2. 4 is going to be 2 times 2, and bring down that other 2. And then n to the 5 would be 5 n's. Okay. 64, I know is 8 times 8. And then I know I can break down 8 into 4 times 2. And then I can break down the 4 into 2 times 2 and bring down the middle 2. Again, 2 times 2 and bring down the middle 2. So 6 2's there. And then n to the 4 would be 4 n's. All right, with 80, that would be 8 times 10. I know 8 is 4 times 2, and 10 is 5 times 2. And then again, 4 can break down to 2 times 2. Bring down this 2, bring down this 5, and bring down that 2. All right, lastly, we got negative 48, so I'm going to treat it like a positive 48. 6 times 8 would be 48. Oh, hold on, I forgot the n's. So again, n3 would be 3 n's. Sorry about that. 6 would be 3 times 2. 8 would be 4 times 2. Break down the 4 into 2 times 2. Bring down that 2, bring down that 2, and that 3. Okay, now you need to handle n2, which would be 2 n's. Okay, so now I need to see what they have in common. I see lots of 2's. So let me start by circling a 2 here, a 2 here, a 2 here, and a 2 here. I see another 2, 2, 2, and a 2. And then I've got one more 2, one more 2, one more 2, and one more 2. Okay, so now I can't take any more 2's or 3's or 5's away because this term over here only had 3. So now I'm going to look at my letters. So So I have 1n, 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 and 1n. And I also have another n, another n, another n, and another n. Okay? So when I put those together, 2 times 2 times 2 is an 8, and then n and n is n squared. So 8n squared would be our GCF for those 4 terms, okay? A little bit of a shortcut, instead of writing all this out, we notice out of an n5, an n4, an n3, and an n2, you take the smallest exponent, okay? So when you look up here, you can only take the smallest exponents away, okay? So that's why this is an n2. And then another shortcut is you can check to see if this smallest number would go into a 64, would go into an 80, and would go into a 48. So if the smallest number out of all your terms goes into all of them, that's automatically going to be your GCF. Okay, so that's kind of a trick to doing these problems. Okay, so let's try this one on your own. So try finding the GCF of this problem, press pause, and we will go over it. Here were my prime factorizations of those 4 numbers. Notice with 45 I got the exact same thing. When you see what they have in common, what you could do is see that they all have a 9 in common right here. So you could just jump to that conclusion that it would be 9. Or you can kind of break it down and saw that they each had 2 3s in common. And so that's why it was 3 times 3, which gave me a 9. Again, you can go by the lowest exponent, so they had 2 a's in common, and so that's why I had a squared. Okay? Alright, so let's try one more, and then you will be experts at finding the GCF of polynomials. So you try these 2 problems on your own, press pause, and we will go over the answer. These 2 problems, on the first one, I got a 7n. When I broke this down, I got 7 times 2 times 2, and then up here I just got 7 times 5, and so they had a 7 in common, so I wrote it down here. Again, the shortcut is to take the smaller of the variables, so just take one variable down. On this one over here, notice I had an 18 and an 18, so those broke down into the same numbers, and over here I had a 10. So don't get confused and want to take 9 from the 2 of them. Make sure they have it all in common, so they each had a 2 in common, so I wrote it down here. Again, the shortcut with the variables is take the smallest exponent. So I had n to the 3rd, and so that was my smallest, so it was 2n cubed. Okay, so now you know how to find the GCF of some polynomials. So if you want to practice that, you can work on A1, GCF of monomials, or you need to watch the next video under this on factoring out a monomial, okay? So your 2 options are to do IXL right now, or you can stay on Canvas and watch video 2, okay? Thanks for watching.